Distributed systems in LLMs project. Description: large language models (LLMs) require significant computational resources for training and inference. Distributed systems enable the effective utilization of multiple computational resources to handle the complexity and scale of LLMs. Components: data parallelism. Description: distributes data across multiple devices or nodes. Each device processes a different subset of the data using the same model parameters. Techniques: synchronous training. Description: all devices synchronize their gradients and update model parameters simultaneously. Asynchronous training. Description: devices update model parameters independently, reducing synchronization overhead but potentially introducing inconsistencies. Model parallelism. Description: splits the model itself across multiple devices or nodes. Each device processes a portion of the model. Techniques: layer-wise parallelism. Description: different layers of the model are distributed across different devices. Tensor slicing. Description: splits individual tensors across multiple devices. Pipeline parallelism. Description: combines aspects of data and model parallelism by dividing the model into stages, with each stage handled by different devices. Data flows through the stages in a pipelined fashion. Distributed training frameworks. Description: tools and libraries designed to facilitate distributed training of LLMs. Examples: Horovod. Description: an open-source library that provides efficient distributed training by leveraging all available resources. PTorch distributed. Description: a PTorch library supporting multiple backends for distributed training. TensorFlow distributed. Description: a TensorFlow library enabling distributed training across different configurations and hardware. Infrastructure. Description: the underlying hardware and software systems that support distributed training and deployment. Components: GPUs and TPUs. Description: high-performance computing units designed to handle the intensive computation required by LLMs. Cloud platforms. Description: platforms such as AWS, Google Cloud, and Azure that provide scalable infrastructure for distributed training and deployment. Challenges. Description: common issues faced when implementing distributed systems for LLMs. Examples: communication overhead. Description: the additional time and resources required for devices to communicate and synchronize. Fault tolerance. Description: ensuring the system can handle failures without significant loss of progress. Load balancing. Description: evenly distributing work across devices to prevent bottlenecks. Debugging. Description: identifying and resolving issues in a distributed environment can be more complex. Optimization techniques. Description: methods to improve efficiency and performance in distributed training. Examples: gradient accumulation. Description: accumulating gradients over multiple mini batches to reduce communication overhead. Mixed precision training. Description: using lower precision data types e.g. fluorine hexadecaphosphide to speed up computation and reduce memory usage. Checkpointing. Description: saving intermediate states of the model to allow recovery in case of failure. Monitoring and management. Description: tools and practices for monitoring the health and performance of distributed systems. Examples: TensorBoard. Description: a tool for visualizing training metrics and debugging distributed training. Prometheus and Grafana. Description: tools for monitoring and visualizing system performance and metrics. Use cases. Description: examples of LLMs projects leveraging distributed systems. Examples: GPT-3. Description: a large-scale language model developed by OpenAI, trained using distributed systems on massive datasets. BERT. Description: a transformer-based model by Google, utilizing distributed training to handle large corpora and achieve high performance on NLP tasks.